we are going to do a triangle proof given quadrilateral SCAM. We are going to prove that triangle SMA is congruent to ACS. Our givens are that segment SC is parallel to segment MA, and that angle S is equal to angle A, which is 90 degrees. A warning: we don't want to believe our diagram. This diagram is intentionally drawn improperly. You can draw your own diagram, or you can use the diagram given in the problem. We want to believe the mathematics, not necessarily the picture that we're given. So we can believe that these lines are parallel even though they aren't truly parallel, and we can believe that this angle and this angle is 90 degrees even though it's not truly 90 degrees in the picture. From here we're going to move from our givens with the ideas that we're picking up from the picture, and we're going to move toward proving this statement. The first thing that we're going to notice is that if we have this line and this line parallel with this transversal CA and having a 90-degree angle between the transversal and this parallel line, by the perpendicular transversal theorem we have that angle C must also be 90 degrees. By similar argument, we're also going to have that SM is a transversal between these parallels, and SC and SM are meeting at 90 degrees, and by the perpendicular transversal theorem we are going to have that angle M is also 90 degrees. Now, given that these two are parallel and that we have 90-degree angles here, we know by an extension of the definition of parallel lines that they are everywhere equidistant from one another, so we can use them as a measuring device to know that the distance between CA is the same distance as that between point S and point M. Further, we can state that SM is congruent to CA by the definition of congruence. The next thing that we're going to do is that we're going to take a look at this segment SA. This also creates a transversal between parallels, and we're going to use that to determine angles. By the alternate interior angles theorem, we can find that MSA and CAS are congruent angles. We are also going to notice that SA is a shared line between this triangle and this triangle, so SA is congruent to SA by the reflexive property to have side, angle, side here that we've identified. As we move down and look at our proof reasons here, we had this side identified by definition of congruence. We had these angles identified by the alternate interior angles theorem, and then we had these sides identified by the reflexive property of segment congruence theorem, giving us side, angle, side, and we have triangle SMA is congruent to triangle ACS by the side, angle, side congruence. And that concludes our proof, which was to be demonstrated.